Hello viewers, welcome to my channel Jaja Academy Lahore. I'm Tabinda Aitzaz. Today we are going to discuss functions in C programming language. In programs we have made so far, the complete program was written inside the main function. This style of writing a program is called unstructured programming. The whole logic of a program is implemented inside the main block, inside the block of main function. All lines of codes are written inside one main block. In today's lecture, we are going to discuss another style of writing program called structured programming approach. In structured programming approach, the whole logic of a program is divided into smaller modules. It is just like we have a big problem, and in order to solve a large or big problem, we divide it into smaller parts, and those smaller parts are known as modules or functions. In this diagram, you can see there are multiple modules, multiple parts of a program. This module's name is F1 or function 1, function 2, F3 and F4. The modules or functions that we create must be called inside the main block, inside the main function. How a function is called, we'll see later in this lecture. At the moment, it is sufficient to understand that every module or every function is called from the main function, and a function which is not called from main function is never executed. You must be thinking, we were going well with the unstructured programming. We had no problem with it. Actually, we were working on smaller programs. Unstructured programming is good for small programs, but when we have to write hundreds of lines of code, it becomes very difficult to manage the whole code in one block. And if some error occurs, it is really very difficult to debug that program. Debug means finding and removing errors from the program. So it becomes very difficult to find error from hundreds or thousands of lines written inside one main block. That's why we divide the large program into smaller parts that make it easier to understand and handle the program. Let's discuss the importance of functions. In some situations, we have to repeat a piece of code, and repetition of piece of code makes a program too large to handle. So we use functions to make programs easier to code, easier to modify, easier to maintain and debug. The next point is reusability. Reusability means using one thing again and again. The standard library of C language is the best example of reusability of functions. So one function may call another function as well, such as inside the main function we call scanf function, printf function, the get function and so on. So functions can be executed as many times as they are required. The next important point is less programming time is required. As the whole programming logic is divided into several parts, so multiple people can work on those parts simultaneously at the same time, which saves a lot of cost and time. Okay, let's see the formal definition of function. A function is a named block of code that performs some action. Named block of code. It means it is a block in which code is written, and that block is given a particular name, and that name is called function name, and that block of code performs some action. There are two types of functions: built-in functions and user-defined functions. Built-in functions are also known as predefined functions, and these functions are provided as a part of C language. For example, printf, scanf, we don't need to declare them. We don't need to define them. They are predefined in C language. Such type of functions are called built-in functions or predefined functions. We simply have to use them, and in order to use them, we include the library file where their declarations are provided. For example, printf, scanf both are defined in the standard input-output library of C language. So whenever we have to use printf or scanf function, we include the header file or the library file standard input-output where these functions are predefined. The other type is user-defined functions. Look, although there are many built-in functions, but still they are insufficient to fulfill the user's requirements. So users themselves have to write functions according to their requirements. And the functions created by the users, the end users or the programmers are called user-defined functions. For example, user can assign any name to his function like ABC, like XYZ, and so on. When we have to use user-defined functions, we don't need to include any header file. Let's discuss how do we write functions in C language. Writing functions in C. The very first line of a function is called function header, and it provides three types of information. Type of return value. Returning a value by a function is optional. A function may or may not return a value. If we don't want a function to return a value, then we use the void keyword before the name of function. But if we want a function to return value, then we have to specify the return type of that function. And return type is the data type of the value that a function will return at the end of execution. We'll understand this concept with the help of example shortly. The second type of information the function header provides is name of function. After the return value, the name of function is written. And then inside the parenthesis, a list of parameters is provided. Parameters or arguments are the values that are assigned to a function. After writing the function header comes the body of function. The body of function starts and ends with curly braces. Inside the body, we can declare variables. If we want to use some variables inside the function, then we can declare variables inside the body of function. The actual programming logic is implemented inside the function body. For example, if I want to add two numbers, my program's logic is to add two numbers. So the actual addition process will be performed inside the body of function. Another type of information a body may contain is a function may call to another function. As we have seen, main function calls the printf function. Main function is a separate function. It calls to another function, printf function, scanf function, or any other function. So the function call is written inside the body of a function. Another very important information is return statement. It's an optional statement. If a function returns a value, then it is returned by using the return statement. Let's understand all these concepts with the help of an example. This is a user-defined function in which there are two main parts. The function header, this is the function header, and this is the function body. The body starts from this curly brace and it includes two statements. Here the body ends. Inside the body of function, return statement is used. First we will discuss the function header. Int is the return type of this function. Then comes the name of function add. Add is the function name, followed by list of parameters written inside the parenthesis. This complete line is called function header. The return type mentioned in function header is very important because it specifies the data type of the value that will be returned by a function. As the return type is integer, So the value returned by this function is sum, and sum is an integer variable which is adding two numbers, two variables of integer data type x plus y. The second part is the name of function, and it must be a meaningful name. The parameters are optional part. It totally depends on the program's logic. These two parameters provide the information that when this function will be called, two values will be given as argument inside these parentheses. For example, suppose the value of x is 4 and the value of y that was provided as argument while calling this function was 5. After the function header, the control is transferred inside the body of function, and the first statement that is written in this body is int sum. Sum is an integer type of variable which is storing the sum of variable x and variable y. The value of x is 4 and the value of y is 5. So 5 plus 4 plus 5 is equal to 9, and this 9 will be assigned to this sum variable, and after that in the second statement the sum variable is returned by this function. So 9 is returned by the add function. As we have mentioned in the function header that the return type of this function will be integer data type, so we cannot return any value other than integer data type. Similarly, if you want to return a character value, then the return type here will be char, character, in place of int keyword. Now let's see how do we call a function. At the start of this lecture, we discussed that every function in a program must be called from main function. These are different functions. Function 1, the body of function 1. This is the second module, function 2. Third module, function 3. These are three separate functions which are called inside the main function. The execution will start here, then the control will be moved to the next line. Next is the body of main function. The first statement inside the body is, this is a function call. It is calling the function 1. When compiler reads a function call, the control is transferred to the function being called. Then this complete function is executed, and at the end, the value returned by this function is sent back to the calling function. Then next statements are executed inside the main body. Now suppose another function call is found. The control will be moved to the function that is being called here. This is the function. Now the function will be executed, and at the end the control will move back to the next line from where it was called, and following statements will be executed. After that, another function call is found. Now the control will go to the body of this function, function 3. This function will be executed completely, and then control will move back to the point from where it was transferred to the function being called. Afterwards, the remaining statements will be executed, and now there is another call which is called to function 2. Now the control will be transferred to the function 2, body of function 2. Here you see the control is transferred from main function at this point to the body of function 2, and after executing the body of function 2, now the control will move to the same point where it was called, and then remaining statements will be executed, and so on. This is how control moves from calling function to the called function. The next very important term is function prototype, which is also known as function declaration or function signature. All three terms are same. The function prototype is same like the function header except one difference, and the difference is of semicolon. A semicolon is placed at the end of function prototype or when we declare a function. As like the function header, the function prototype also provides three types of information. The return type, which is integer, the function name, which is heading, and the parameters or arguments, which is void here. Void means nothing. This function contains no parameters, no arguments. But unlike the function header, the function prototype is ended with a semicolon. That's why it is also known as a statement, because statement is ended with a semicolon. So a function prototype is a statement. A question arises here. When do we use function header and when do we use function prototype? The function header is written just before the body of function, where the actual function is written. But the function prototype is just like introducing a function in a program. We have to provide function prototypes of all functions that we use in our program. And the function prototype is written outside the body of function. So it is recommended to write prototype of functions after the preprocessor directives. When we talk about variables, we can use a variable only when we have declared that variable in our program. For example, if I am using a is equal to 10, then the variable a must have been declared before writing this statement, above this statement, like integer a. Similarly, if I want to write a function heading, then it must be declared before writing the actual function. Suppose this is the actual function int heading and this is the body of heading function, the function heading. This function must have been declared before using this actual function. As I can use the variable a after declaring it. Similarly, I can use this function only after declaring this function. The function declaration is always ended with a semicolon, whereas the actual function is not ended with a semicolon, but it is followed by the body of function. Now let's see a sample program that will provide a recap of all the concepts discussed in this lecture. These are three integer variables a, b and c. The second line is function prototype. Remember one thing, function prototype or function declaration statement is always written outside the body of function. The return type of function is integer, the name of function is product, and it contains two parameters, integer x and integer y. This line is providing us information that there will be a function written in this program and the name of function will be product. This line is also known as function signature. The next is main function. This is the body of main function. Int main void. There is a noticeable point. Int main. We have been using void main so far. As we used void main, so main never returned any value. But here we are using int main. It means the main function will return an integer value. It may be a 0, it may be any other integer value. The first statement inside the main function is a function call. At this point, the control will move to the body of product function. Here, integer x is receiving the value of a, which is 10, and integer y, the variable y, is receiving the value of b, which is 5. Then control will move inside the body of function, and the body of function contains one return statement. This return statement is x multiplied by y. It means 10 multiplied by 5 is equal to 50. So this function, the product function, is returning 50. At the end of the execution of this program, this function, the control will move back to the function call because the execution of this statement was not completed as there is a assignment operator. Now the value 50 is received by this function call and this 50 will be assigned to the variable C. Now the control will move to the next line, which is printf statement, and it is printing the value of C, which is 50. The output of this function is 50. Now the control will move to the next line, and the next line is return statement and it is returning 0. The execution stops here. Remember another point, when compiler reads the return statement, the function is terminated. The execution of function is stopped. So make sure to write the return statement being the last statement of a function. Because if you write any number of statements after the return statement, those lines will not be executed. Thank you for watching. If you have any problem, any question, you can ask me by writing in the comment box. For more computer science lectures and other informative videos, subscribe to my channel.